with specific speeds, which we had derived the expression yesterday. The equation we derived was actually shape number NSH, which was n root q by gh power 3 by 4. That will be fully non-dimensional, whereas in the field people use specific speed denoted by n root q h power 3 by 4. G is removed, and with that the values you get is good numbers like 10, 30 or 500, like that. If you divide this by another g, you get some fraction and things like that. So this is what is used, and for this n should be in revolutions per minute, not revolutions per second or radians per second, but revolutions per minute. Q is meter cube per second, h is meters. So here you have different types. 10 to 30 is slow speed impellers, 30 to 50 is medium speed, 50 to 80 is high speed. So they are all centrifugal pumps. When the specific speed is 80 to 160, you go for mixed flow pumps, and when it is 110 to 500, it is axial flow pumps. Okay, so if for the given duty, if you get the specific speed value to be say 50 to 80 range, you have to go for the centrifugal pump design only. If you don't, hello, can you see that? Okay.
Yes.
So if you don't design a centrifugal pump, and instead if you design an axial flow pump, the efficiency may not be that high. So these numbers, they are related to the corresponding shapes that produce very good efficiency. Okay, these numbers provide the meridional shape. Okay, we had in the earlier class itself introduced the meridional cross section. Okay, the cross section containing the axis. Even our classification, axial, radial and mixed, depends on the flow path in the meridional section in the rotor or the runner. Okay, so these numbers provide the meridional shape for the most efficient pumps. The main pumping duty is Q the discharge and H the head. So by selecting suitable value of n, one can design centrifugal or axial. That means there is some leeway, by choosing n, you can go from centrifugal to axial like that, but n also there could be limitations. You can't have extreme values of n. So for a particular duty, sometimes you may have to go for centrifugal machine, and for some you may have to go for axial flow pumps. Okay, now suction limitation. Okay, now take this case. Okay, you have a sump filled with water, and a pump draws water from that. There's a motor connected to the pump, and at the exit of the pump there's a valve. Now you start the motor, open the valve, the pump will start pumping water. So this type of suction is called flooded suction, where the pump is kept below the water surface. Okay, in flooded suction, the pump is kept below the water surface. There is no suction problem here. Now take this case. The pump is kept above the water surface. Now here also, you start the motor, open the valve, the pump does not pump water. Why? As you see that, you need an operation called priming that has to be done before starting the pump. And what is this operation? It is filling of the suction pipe and pump casing with water. Now take this case. So here also you have a sump, the same pump. The suction head is 5 meters. Now for priming, you have a small extra fitting. So a small tube, and in the tube there is a small valve is there. Then a funnel is kept through which you can pour water, and you can see that the complete suction line and the pump casing is filled with water. And you see at the bottom of the suction pipe, the red color one, that is actually a strainer, that is a filter plus a small valve. This valve will allow water to move up, but it will not allow water to fall down. Okay, so it's a foot valve, it is called, because it is kept at the bottommost position. So now you have to prime it. For that, you have to pour water through the funnel there, and once you find that it is full, the water in the funnel will not flow inside. You can now start the motor, open the valve, and the pump will start pumping water. Now take this case. You have again a sump. The pump motor is kept at a height of 15 meters. After priming, start the motor, open the discharge valve. Well, I have not shown a valve here. I missed it. The valve will be there most probably. It may not be also there. Now the pump does not pump water. Why? It is primed. You have a foot valve in the bottom and it is primed. This is because of suction head limitation. Okay, this will be discussed in the next slide. See, you have the suction head limitation, that is water in the sump is not pulled up by the pump, but it is pushed up by the atmospheric pressure. This is what is very, very important to understand. The pump does not pull the water up. It cannot exert any pull force, but the water is pushed up by the atmospheric pressure, which is acting on the surface of water in the sump. This pressure only produces the barometric head, which is around 10 meters of water column. So you are all familiar with barometers for measuring atmospheric pressure, and the most common barometer is the mercury barometer. So with mercury, you get about 760 millimeters of water column, or 0.76 meters of mercury column. That is called the standard atmospheric pressure. It might vary at higher altitudes. It may be less. In some places, it may be a little more depending on the air currents and all those. Now, if I consider a barometer made out of water, the barometric column will be 10.3 meters. So the atmospheric pressure on the water surface will be able to push the water up to a column of 10.3 meters. Now above that, I have left some space. Some vacuum will be there, maybe filled with the vapor pressure, not full vacuum. In some places they call it the torricellian vacuum. So above that, some vapor pressure will be there. Okay, because corresponding to the temperature, vapor would have formed, that is, water would have vaporized. So corresponding the temperature, the vapor is there at the top and it will exert a vapor pressure. Okay, now coming to the suction head limitation. When the suction lift HS is more than 10 meters, water cannot flow into the pump to get energized by the pump. Okay, so if we have a 10 meter barometric tube, water will rise up to only 10 meters. Even if the height of the barometric tube is 20 meters, water will go up to only 10 meters. Above that, the vapor pressure or vacuum is there. So in the suction, maximum height you can provide is about 10 meters. That also is not exactly 10. You have to give way for the vapor pressure and the head losses. Okay. Well, now we will see the centrifugal pump characteristics for constant speed. Okay, so this has to be done in the laboratory. You have the centrifugal pump connected to the motor and the suction pipe. In the suction pipe, you will have one pressure gauge. Delivery pipe also, there is a pressure gauge. Now, depending upon the valve position, you can control the volume flow rate. Okay. Now, already we have seen the head characteristics. You have maximum head, when the discharge is 0, it has a particular name. So it's called the shut-off head. Then when you open the valve, flow will take place. Correspondingly, the discharge will start increasing. You will find that the head will be decreasing. And for each situation, one can measure the power supplied to the motor and maybe multiplied by some efficiency. You can find out what is the actual power given to the